It's the first session after lunch. Is everyone awake? Who's on their second coffee of the day? Few hands. More than two? Oh yeah, okay. Really adding to those 8,000 coffees that is predicted to be the number of coffees given out this 2 days. This is my first time in Croatia, and I actually got here on Friday because it's really hard flying from San Francisco all the way over here. And I spent a few days walking around town, and one of the things that I noticed doing that was that no matter what time of day it is, people are always drinking coffee here at the restaurants. It's like lunchtime, you got 3 guys at a table with a coffee, no food, just coffee. Mid-afternoon, morning, dinner time, still coffee. It's obviously a big coffee culture, so that was cool to see. So before we jump into the topic at hand, I wanted to take a second to introduce myself. So again, my name is Christine Spang, and I'm the founder and CTO of Nylas. To give you an idea of sort of what my background and perspective is, I'd love to tell you what Nylas does. Nylas is an API platform that makes it really easy for all you folks, developers, to connect any email account or calendar account to the back end of your application. So what that means is that we build integrations so that you don't have to. Whether your end users are on Gmail or Microsoft or an old Exchange server or GMX or Zoho or even an old IMAP server that is hosted in their basement, if you use Nylas to connect that account to your app, you can access the data, you can send and automate workflows, and you can do all that without sort of worrying about the protocol details of what's happening behind the scenes. So we have thousands of developers that use the platform to build apps, to automate workflows, to access data, to feed data to their AI models. And if that sounds like something that's useful to you, I'd love for you to check it out. With that, I'd love to sort of dive into the topic that we have of really what is the future of generative AI? So every new technology that comes out goes through a hype cycle. And I am based in the San Francisco Bay Area, which is like the capital of hype cycles. And I think it's worthwhile to just take a second to frame sort of where we are. So from my point of view, the time that generative AI really went mainstream was when OpenAI launched ChatGPT, which was in November of 2022. And obviously, that's like not where the origin of the technology was. We've been working on machine learning technologies for decades. And generative AI existed before ChatGPT. Large language models existed before ChatGPT, but generally, it didn't work very well, and also, like, nobody really knew what they did. So ChatGPT kind of brought it to the mainstream because it really illustrated the capabilities of the technology and sort of how it was a leap forward, especially for things like chatbots, which obviously we'll talk a little bit about later on. So the next thing that happened was that all of the sort of media press around tech was like, wow, AI has got so powerful, I can talk to it and have like a regular human conversation. And obviously this means that we're all going to lose our jobs tomorrow and the robots are taking over, we're doomed, layoffs are happening. Actually even had engineers on my team like express anxiety to me about like, you know, am I going to have a job in the future? Like, what's happening? But kind of as happens with all hype cycles, reality starts to kick in once you get past that initial phase of just dazzlement of sort of seeing a new leap forward. And that's where all kind of the real work happens. I've seen over the last few months where sort of the hype is coming back down to earth. And I shared a few news article headlines in sort of the graphic, but people always go into this state of disillusionment once they realize that it's not a magic pill, a new technology, and it's not going to fix all their problems tomorrow, and maybe it's not worthwhile anything at all. At the same time, I've been to a few of the sessions, actually even here at InfoBip, where it's clear that the practitioners on the ground are figuring out how do we implement this stuff? How do we build features using generative AI that are useful? What are the best practices that we should be using? And sort of turning it from the Wild West into something that's more of like an understood technique that's on the tool set of engineers that are out there. And it's just one tool that you'll apply to a certain set of problems. And at the end of the day, after the hype cycle plays out, the deployment of a new technology always converges on value. And what I mean by that is that, instead of sort of everybody jumping on and saying, like, if we don't use generative AI for something in our app, we're going to fall behind, people identify where are the places that this is something that really makes sense to have a huge leap forward in terms of the user experience or kind of what you're able to do. And people only start building and deploying and using the technology in those particular use cases that are useful. And where they're not spending a ridiculous amount of money for less than an amazing amount of value. So that's kind of where we are. And another high-level point I wanted to make is that obviously when we talk about AI, when I speak to engineers, like, we're obviously talking about technologies that involve models and learning from data. But what I see at sort of the bigger picture here is that computing is about more than just models and learning. It's really a higher level thing where we're using technology to generate leverage. And what I mean by leverage is to have small inputs that create really big outputs. I'm sure we've all had the moment of excitement when you create something from nothing, as developers. I think that's one of the things that draws people most to being software people. Or implementing a script where you can take a set of work that by hand would have taken days or months or even years and turning that into minutes, perhaps, or even seconds. So AI is a piece of how we're using computers to generate leverage. And again, generative AI is one tool within AI, within computing, that is useful in specific use cases. Today, I think we've picked the lowest hanging fruit, and I've identified some places where obviously generative AI is a big leap forward. Things like chatbots, the original use case. Things like automating first-tier customer support, where people were designed and have learned from a young age to talk to another person. And that's something that's a lot more natural to people than sort of reading books. Everybody talks to other people every day. Not everybody reads books every day. So it's a natural format, and it's something that just makes the experience of accessing documentation, sort of internal knowledge bases, a lot easier. And of course, probably everybody here in this room has used a coding assistant at certain points. I think we're also seeing this get extended to things that are not assistants for coding in specific, but also for sort of general purpose co-pilots that help you navigate the context of certain scenarios. And these are use cases that folks have identified where the technology today can be productionized in a useful way. And there are places where the use case is resilient to the pitfalls of building in production with large language models. Things like you have to be okay with having a small but real sort of error rate, hallucination rate, where things are just wrong. And it really helps if, like with things like with code, if it's something that's verifiable, like you can always execute code and make sure that it actually works. So these are sort of things that you've probably all used and made use of and seen in action. And we'll talk about this a little bit more later, but this context piece is something that I think is really important. I'm not going to berate this. This is just an example of sort of a support chatbot in action. We deployed a support agent, a chatbot, to our own internal developer documentation. That's actually available on our website. And We found that decreased tickets by a very significant percentage of people just not being able to find the right thing, which is cool. That's something that's really valuable, and it's also cheap and easy to implement. So what is next? To answer this question, I want to introduce this high-level concept around communication. All sorts of really valuable information is exchanged in the communication that we do with each other. Whether that's talking live, whether that's sending emails, whether that's making phone calls, whether that's writing things down in documents. Most of the context of how we sort of put the world together happens in communication. Because at the end of the day, if you're not going to share information with somebody else, what's the point of writing it down or saying it out loud in the first place? And the ability to communicate and to organize information is really the limiting thing in how people are able to collaborate and to work together. Before we had writing, we couldn't really work together in groups more than sort of small groups of like family-style tribes, because you couldn't convey all the context that was necessary to get things done with a wider group of people. So you have to have shared language, and you have to have ways to kind of convey information to other people, and then computing has really extended upon that by giving us the ability to process that information at vast scales that we weren't able to do before. So there's really valuable data in that communication. And we need to be able to essentially take the right context and pass it to applications in all sorts of different use cases. If you've been to any of the other talks at this stage, there's been a few practitioners who've been speaking about things about really like how do you build apps with large language models. And everybody mentions that you need to pre-process data to pass it to your large language model and provide context to it. And then you also need to sort of post-process what's coming out of it to make it work in a real-world production application. And when I talk about context, what I'm really talking about is like, how do you find and select the right information to put in that sort of pre-processed context? And obviously the techniques are evolving. There's things like RAG and other ways to have broader context. But we essentially have a generalized technology right now that's been a big leap forward. And the job of us and all the people that are building products over the next couple of years is to find places where there's relevant context and really valuable, high-value information, find the right way to pre-process that data and information to pass it to this technology in certain use cases where it's applicable, and to use that to really sort of superpower what people are able to get done in specific use cases. So one thing that I've seen just as someone who's running an API platform is that people are building apps in all sorts of different places where they're bringing context together. And I think large language models are a really amazing new piece of technology that helps with processing and dealing with sort of all of this context. But if you're trying to get something done in any sort of specific use case, you want to have all of the relevant information at your fingertips in order to do that thing. So app developers these days, they don't want to sort of send people off to go do something in their email and go do something in chat. They want to have all of that context put together in that app. And large language models are really a generalized technology. I think it's really cool that machine learning sort of went through this, and large language models really come from deep learning, but I'm not going to rabbit hole too much here. But I think a few years ago when people thought about machine learning, the things that were really working were sort of really specialized use cases where people would build a model for like this one specific thing, and you could do that with sort of properly labeled data. But one thing that's really cool about generative AI and large language models is that It's a general purpose technology. And so now what we have to do is not start from having the specific use case and building a end-to-end specific learning technology for that, but we have to take a general purpose learning technology and generating technology with a sort of a model behind it, and we have to customize it to the context and the use case that we want to superpower. So I think that one thing that's going to happen sort of across the board with applications is that people are going to take each individual use case where this makes sense and find all of the relevant context data, figure out how to pre-process that. Generative AI is sort of one piece of the tech stack to make this happen, but it all comes down to driving action at the end of the day. And without that really contextual data and information, you can't help people do the right thing. And usually when people are using software, they're trying to get something done. Another thing I wanted to talk about is compound systems. There's a really cool blog post and a paper as well that was earlier this year. I would say recently, but in sort of AI years, it's not recent if it was 6 months ago. There's this paper and blog post posted by the Berkeley AI Research Laboratory called, I can't remember the exact title of it, but basically if you Google for compound systems and BAIR, you'll find it. And what it talks about is how you basically can't bring to production just a production-ready feature that doesn't require multiple steps and combining multiple technologies together. I've seen this upfront and personal at Nylas, where we have used large language technology to essentially to extract data from email. And if you just sort of do the basic thing, which is like pipe all these messages to a large language model, it doesn't work. So there's a lot of software engineering that needs to happen in order to create a system that actually works in production. And that's something that's really complicated. So I think it's heartening for folks that don't have a specialty in, in sort of the data engineering or the data science side of AI and machine learning, that there's a lot of just sort of rote engineering work that needs to happen in order to make something that works at scale in the real world. And that requires thinking in terms of compound systems. I mentioned before, we have a product called Nylas Extract AI that what it does is it allows you to extract structured data from email messages and get output from that. This is something that, if you were working at a small scale and you had a specific set of messages, you could just take those messages and drop them, to the OpenAI API and get some data back without really doing a whole lot of work. But if you want to do that in the real world at scale, that's not something that works. One, it's like way too expensive. Two, like the input is really hard to understand and there's a lot of sort of garbage in there. And three, you need to deal with those problems that I mentioned before, which is things like hallucinations and accuracy. And so in order to make this work at scale in sort of a cost-performant way, we had to take large language models, sometimes different models, and combine that with sort of performance engineering and back-end infrastructure to get creative on how do you actually take this technology and make it useful. But this is also another example of something that's not a chatbot and not something that's like a knowledge base, where large language model technology is something that is really key. And the reason that it's really key in this kind of place is because it's working with taking unstructured information and unstructured text from communication, and it's turning that into something that's much easier to connect to other computing systems and to essentially integrate with the rest of the world of software engineering. So I think that one thing that's really powerful is this essentially a leap forward in how we can take unstructured information and turn it into structured data that is then easier to work with. And I think that one thing that's going to happen over the next couple of years is that generative AI technology makes it more flexible in terms of how we have applications that are communicating with each other. When people are talking to each other, obviously we have conventions, we have languages that we know that allow us to communicate and have the other person understand. But it's a much more free-form way of communicating than the historical patterns in terms of how computer systems have communicated with each other. And one thing that large language models enable is because large language models have been trained on a huge corpus of text and sort of mathematically encode the patterns of human communication, that allows sort of APIs and the way that computers talk together in sort of structured ways to become more flexible and less structured over time. So in this case, this is giving an example of an e-commerce app that wants to digest purchasing information from email messages. And this is something that you can't just sort of send a blob of HTML to that other app. It wants to know, what was the purchasing price, what was the label of the item, and sort of standardized fields. And large language models end up being the bridge between this unstructured human communication data and this sort of legacy existing technology world where everything needs to be very structured in order to work with it. I feel like in software engineering, the fact that structure is so required is why a certain type of people really thrive in engineering jobs. My business partner likes to make jokes at me about how coding is so frustrating because, if you place a comma in the wrong place, the whole thing blows up and nothing works. And as someone who has a sort of deep engineering background, that's not something that's surprising to me, but it's not how most people work. And one of the things that I think is so interesting and so exciting is that by bridging this sort of structured requirement of how we've built up computing systems to how they are today with essentially the sort of messy world of human language, we can enable people that really haven't had access to the leverage of computation before to have that power, which I think is something that is really exciting. We have a few minutes left here, but I'd love to sort of sum up some of the key takeaways and also talk a little bit about just the big picture of AI tech in general. One is, so we talked about this really early on, so we're going to get to a place where people have good ideas of where can you deploy generative AI usefully and have that be the right tool for the job because it delivers more value than it costs to implement and to build and to run also. That's something that is evolving really quickly right now, being able to understand how things cost in production and also being able to get feedback. The second point that I wanted to make sure that everyone takes away here is that this communications context is kind of the key for how we're building applications that use generative AI technology over the next couple of years. The renaissance that there is to have is by finding places that have a use case that, one, involves human language to use. Two, there's some specific set of context that is relevant there, and then figuring out how to take that context and hook it into generative AI and other tools to make an entire system that is useful for those folks. And I guess that sort of encompasses the third point that I wanted to make here and reiterate, which is that all of these systems are going to be compound AI systems. We've always taken technology and hooked it together in creative ways to solve problems. And one of the things that really frustrates me with these hype cycles is that there's always this period of people jumping to, oh, there's this brand new technology, it's a magic bullet, it's going to solve everything, when that's never the case. There's never been one technology that sort of makes all your problems go away. Even if you have a use case that is relevant for generative AI, there's a lot of work that has to happen in order to actually make something useful in production and at scale. And they also introduce some challenges that we're not super used to working with before, like the fact that is non-deterministic. They can be sort of seen as a black box. When you're in production, you have to figure out, how do I evaluate what's good and what's not good? What do I do when things are wrong? And I think all of these problems are solvable, but only in specific use cases where the use case essentially has tolerance for not having perfection, because I don't think the current iteration of technology is going to get to 100% no hallucinations, 100% predictability, things like that. So you have to essentially use standard software engineering techniques to put in guardrails, to take that output from the LLM and make use of it in the right way. Sometimes do different things depending on what you get back. And at the end of the day, I think that everybody is sort of converging in this direction at this point, but I think we've moved away from this world of just feeling like AI is going to take our jobs, and see that these technologies help automate tasks and pieces of things that we have to do every day, but they help elevate us to a higher level. And the most exciting thing about that for me is because when you can operate at a higher level, you can essentially own problems more end-to-end, and that's something that is much more motivating as a person. I'm someone who has always worked and started my own company because I didn't want to be a cog in sort of a big machine where you only sort of know, like, this is how this particular widget works, and it has input A and gives you output B. If we can own problems more end-to-end and be the problem solvers, that, in my view, is just a much more exciting way to exist as a person in the world. And I think what's going to happen is it's going to allow us to collaborate and work together in new ways that we haven't predicted. That, when people invented language, we didn't know it was going to happen, how it was going to spread, how it was going to enable us to do different things. And I think that as we keep seeing sort of these improvements and leaps forward, people will be able to own those problems more end-to-end, and you'll have a lot more people that are free to tackle different problems. So I hope that everyone here in this room is inspired to, one, use the right tool for the right job, really focus on being practical, and two, don't be scared of the robots taking over. I think the robots are here to help us, and it's our job as software developers and engineers to take this right context and give people tools that allow them to essentially make a bigger difference in the world. Thank you.